Welcome to the Feria TechCast, where we bring you all things science, engineering, technology, and innovation. Today we are joined by Bhaskar Sawant, an AI architect and cybersecurity innovator with over 15 years of experience building intelligent, adaptive defense systems. He specializes in blending deep software engineering expertise with machine learning to create security solutions that can learn and evolve in real time. He is also an IEEE Senior Member and a passionate advocate for explainable and responsible AI. In this episode, we'll dive into the architecture of adaptive cyber defense and how AI is reshaping the future of digital security. So, Bhaskar, welcome to the show.
Thank you.
All right, I am excited to have you. So, quickly, let's start with your presentation on security isn't a tool, it's a habit.
Right. So, thank you. Thank you very much for the kind introduction. My name is Bhaskar Sawant, and I have around 15 years of experience helping organizations to automate the workflows, reduce manual bottlenecks, and use the data to make the stronger decisions. Over the last few years, my focus has been on helping the teams shift from being reactive to being proactive using the AI, especially in the areas of pricing systems, cybersecurity, and operational efficiency. Uh, Today's topic of we are exploring is something we have observed over and over again in a real world system and the teams. Security is not something you can achieve just by buying the right products or adding the latest tools to your tech stack. Instead, security is something that is developed through repetitive behaviors, habits, and shared team culture. We often think of security as a technology, fireworks, scanners, MFA, encryption. Those are important, and we absolutely need them, but the real strength of the security comes from the people using the tools, how they behave day by day. There is a common mindset in the organizations that says if we purchase the right tools, we are secure. You will hear things like we have firewalls, so we are covered. We install the MFA, so we are safe now. We brought an endpoint product, so attackers can't get in. But purchasing a tool doesn't not equal to being secure. Tools assist, but they do not replace the secure habits. The best analogy is fitness. Owning a treadmill does not automatically makes you fit, right? You have to constantly use it, build routine around it, and maintain the discipline over the time. Security works in exact the same way. Tools are the equipments, and habits are the exercise. So, what does the habit mindset looks like in the practical terms? First, security is a continuous, not an item you just check off once. It's not we implemented MFAs, so we are done. It's more like we continuously evaluate, improve how we automate. Second, habits are small actions done consistently.
Hmm.
Things like reviewing access permission regularly, checking logs instead of assuming everything is fine, asking should this be particular publicly accessible, or verifying dependencies, updates instead of clicking later. These small habits or actions compound over time. And finally, you will reinforce these behavior across the teams. It becomes a part of the culture, where the security by default becomes the natural way people work without needing consistent reminders or audits. Let me share a real world example from my own field. There was a system that had strong MFA policies, encrypted storage, uh, properly configured firewalls, good role based access control. On paper, everything looked excellent. However, during the tight deadline, someone told a colleague, just use my login, it will be faster. The moment that password was shared, every layer of security collapsed. All the encryption, MFA, firewall doesn't matter because access control was bypassed at the human level. This story highlights something very important. Security fails fastest when the habits were weakest. You can spend millions on technology, but single insecure decision, even well intended, can undo it all. I can give you one more case which I observed. A team did something we usually consider great security practice. They patched their server and updated the application libraries. But what they didn't realize was that the CI/CD build image they were using was outdated. So even though production was patched, the pipeline kept reintroducing the old vulnerabilities into the new build. This is very powerful reminder. Security isn't just about the final environment, it's about the entire life cycle. If one link in the chain is weak, the chain still breaks. Security should be viewed as a whole, not just one layer or a step in the process. We have two core principles we can discuss here. The first core principle that supports security habit is a least privilege. Least privilege means where every person, service, or a system gets only access required to perform their task and nothing more. This isn't about the distrust, it's about designing the system that minimize the potential damage if an account is compromised. To apply the least privilege effectively, you can start with no access by default, then grant access only to what is necessary, then regularly review and remove access that are no longer needed, and use the temporary or time limited access whenever possible. If this one habit is applied consistently, it prevents enormous range of security issues. The second principle is to make the secure behavior the easiest behavior. If the secure way of doing something is slow, inconvenient, or confusing, people will find a workaround, and not because they are careless, simply because they're trying to get the work done, right? So we automate the security by as much as possible. Securities can run automatically in CI/CD pipeline. Then we can do passwords and keys rotate automatically. Then templates for infrastructure or and architecture came pre-secured out of the box. When the secure path is the default path, habits form naturally. Even with a good prevention, something will eventually go wrong. That's normal, correct? No system is perfect. What matters then is how quickly we can detect and respond. This includes logging is always enabled and meaningful, then monitoring alert distinguish between the important signals and the background noise. Response procedures are clear, simple, and practiced. Teams know who to call and what steps to take when something suspicious happens. Security is not just about blocking attacks, security is also about noticing early, responding effectively. To make the security habit, we must look beyond the tools and the policies and focus on the culture. A healthy security culture first encourages the transparency. People should feel secure and safe when they are saying, I think we did something wrong. If people fear blame, they will hide problems and hidden problems grows. Second, practice scenarios. Internal tabletops exercises help teams think through issues calmly before emergencies happens. And third, recognize and celebrate the security improvements. When someone fixes a vulnerability or prevents a risk design, we should acknowledge that contribution just as we celebrate the shipping feature. Security becomes sustainable when it becomes a part of the shared identity of the team. To wrap up this presentation, here are core message to remember. Tools don't create security, habits do. Security is not a one-time project, it's a daily practice. Small, consistent improvements are more effective than the large, occasional efforts. And most importantly, your team behavior, the people makes every day, forms the real security boundaries around the system. If you focus on building the secure habits supported by a good tools rather than dependent on them, you create the system that are no only strong today but strong tomorrow as well. Security is not something we wait for, it's not something we buy, it's something we practice. Every email we send, every access request we approve, every shortcut we refuse, these are the moment when the security is built.
Mm,
Tools may strengthen our systems, but our habits strengthen our teams. If we build the habits, the tool will work. If we skip the habits, No tool in the world will save us. That's wrap up the main message I wanted to share. Now we can shift into the conversation and explore your question, perspective, experience around building the secure habits.
All right. Right.
Am I visible now? Okay.
Yes. So that was a really wonderful presentation. So before we, go into questions on that, I'd like to explore your journey. So your journey spans over 15 years from deep .NET engineering to pioneering AI-driven cybersecurity. So for you, what was a pivotal moment that made you see AI not just as a tool, but as a fundamental new paradigm for building defense systems?
Yeah, means I started as a .NET developer, and then I moved into United States in 2015, and then I started working on a major company website. I built that website from the scratch, and as we grow, like the website becomes into the production, the security threats and the people, the attacks we are getting from the outside world, that is the main push I get to actually try to understand how the cybersecurity works. And today's work, today's world, the cybersecurity is the main thing we have to think about because of the attacks, and the people get so smart, and the tools why right now we have on available, it's much easier to become a attacker than the defenders, so that was my main motive to actually get into the AI and the cybersecurity part. Particularly this topic we are discussing today, that is something I came across when I was working with the organization. uh, in my current organization, I can tell you we invest in tools, and those tools are valuable, but they are exposed because everyday shortcuts and the human decisions. So we try to use how the AI can help us to prevent those attacks, how we can use the AI to actually improve our existing system and make it more, safe.
All right. That's an interesting one. So I like to ask a question on your presentation. Along the ending of your presentation, you made a statement: tools don't create security, habits do. So I like to ask, what are some habits you think an organization has to foster amongst the employees to, create security that tools really cannot create?
Right. So as I mentioned in my presentation slides, so basically, obviously, tools are important. They are powerful, but unless we are using them correctly, they are no use, right? How can we start? Like the main thing we can start, like we can start with a simple thing. Just the simplest and most impactful place to start is the access management. Just review who has the access to what, and remove anything that's not needed. Do that in on a recurring schedule, quarterly, monthly, whenever whatever works. These one habits to start with reduce so much risk and usually low effort and high returns. This is the one. And we have to prevent the people from taking the shortcuts. How we can do that? Whenever we think about the security, it has to be implemented as a part of regular thing, right? And it has to be very simple thing. We don't want to make our security architecture too complex, so it will not slow down the organization, but also not slow down the people from doing their work. Unless we can make it more easier to implement into the existing environment, then only people will try to use it and avoid taking any shortcuts.
All right. So again, I'll ask a question based off another statement I heard you say earlier. So a while ago, you said it's much easier to be an attacker than a defender in today's day and age in cybersecurity. So I'd like to ask, what role does AI play in this, game of attack and defense, and who does AI enhance the more?
Okay. So as I said, attackers nowadays using these online tools, or all the AI tools available easily online. Attackers use them to actually use attack the websites, but we can use the same tools and use them correctly to prevent the attackers from get into the system. In one of my presentation last week, I explained how we can use the observability, and how we can use the concept of observability in the AI. How can we use the online tools? Like, I can give you a small example what we did in our system. Like, we implemented Serilog for structure logging, and to understand what exactly happening in our system. You can't prevent anything which you can't see. So the concept of observability in the AI, that will help us to see what's exactly happening in our existing environment, in our existing system. And the attackers, when they try to do attacking, all these logs that can help us to understand what exactly happening in our system. We can use the Serilog for the structural central logging. Then we can use the open telemetry tracking across all microservices that gave us the end-to-end visibility for every request, from API layer to down to the SQL injection, to avoid the SQL injection. And finally, we can integrate everything into the Azure Application Insight or Sentinel. Those are very good tools that give us the full picture of our entire system. The main thing about what I want to highlight here is, whatever tools we have online, attackers can use those tools to attack the website, but we can use the same tools to actually prevent them, or at least see when attackers try to attack our website. um, 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 we can use the same tools.
You're right. So, can you share a story of a time an adaptive AI system you worked on detected a novel attack pattern that traditional signature-based defense is completely missed? Is there any scenario like that?
Yeah, actually, I have a very good presentation about it. Last week, as I mentioned, one of my conferences in Cleveland, we discussed about one particular case. This is what we actually did in our system. That presentation covers what we had before we implement the this AI into our system, and what is the impact after we introduce the AI into our system. This that is also a very small presentation. If you allow, I can run you through that as well. But it's very
Yeah,
very
sure.
yeah, very good presentation. Means people like that one. Okay, got it. Okay, so basically, this particular presentation is about how we implemented the transformation from PowerShell, and PowerShell threat detection, and how we transform our reactive system into the proactive system, and how we used it, what tools we used it, and everything. So here is, I will share the practical story of how our team transformed PowerShell threat detection from being reactive and noisy to become intelligent and proactive using machine learning. This is this is not the theoretical case study. It's something we implemented in our real enterprise environment, where we move from hundred of false alert every day to automated and precise detection that stop actual ransomware activity before we spread. So basically, before this one, we had actually that's me. So like many organization, we had a PowerShell activity everywhere, administrator running backup scripts, automated deployment jobs, and daily maintenance tasks. But attackers were using the same tools, as I mentioned earlier, running encoded commands, downloading payloads, and silently modifying the registry keys. Our SIEM had a simple rule: if the PowerShell with the ENC or invoke web request trigger an alert. The problem, they caught everything, like legitimate or malicious attack alike. We end up with over 100 alerts every day. About 80% of them are false positive. and each one requires a manual triage, 20 to 30 minutes per case. It's become very clear at that particular point that the static rule couldn't keep up, and we have to use the dynamic nature of the PowerShell activity. So basically, we use the PowerShell to reduce the noise we are getting every day from the system to make a powerful and more focused decision. So we have decided to teach the system to learn what's normal instead of just flagging keywords. Using the Python-based ML model, we trained our weeks of PowerShell logs, teaching it how admins behave versus how attackers behave. The model looked at the four main things: who run the commands, admin or normal users, when it ran, business hours or midnight, what it ran, what it did, network or the registry operations, how often similar patterns appears before. When then integrated into the model directly into the PowerShell, whenever the command executed, the PowerShell calls the model to get a risk score between the 0 and 1. If the score below the 0.6, it just logged it. If the risk is between the 0.6 or 0.85, send an alert for a review, and if it's above 0.85, auto containment and the SOC notification, security team notification. This one change, uh, this one change teaching the PowerShell to think was the transformative. The model didn't rely on one signature. It looked at multiple contextual factors. First, user context: was this command run by the admin or the service account? Second, the command characteristics: did it involve the crypto module or network activity? The temporal behavior: was it running off hours or outside the known job schedule? And its environmental context: did the host already have the recent security alert or the abnormal traffic? By analyzing the behavior in the context, we stop punishing the good admins for doing their jobs and focused on truly suspicious events. I'm just sharing the small piece of a code here, a simple single piece of code of the PowerShell. It's this small, and this is very small code, but it's very powerful code. This code runs automatically on every PowerShell event, assigning a threat score and taking the right actions instantly before analysts even see it. Within the first month, we saw a measurable impact. Alerts per day dropped from around 120 to just 30. False positive dropped from 80% to 15%. Average response time improved from 25 minutes to just 5 minutes. And most importantly, we had a 6 confirmed threads automatically contained before they could execute. In short, 25% fewer alerts, 65% fewer false positive, and 80% faster response time. If you are considering doing something very similar, here is the proposed, means what we have done in our system. First, we collect the data, gather at least 2-3 weeks of PowerShell logs, who ran, what, when, and where. Then train your model. Use the scikit-learn or similar libraries to learn normal versus abnormal behavior. This is very important because unless your system knows what is normal, it can't identify what's abnormal, right? The third step is integrate, update the script to call the ML model and retrieve the risk score. Then automate the response, isolate the high-risk system and notify the security team automatically. Review and retrain weekly. Analysts validate alerts and feedback makes the model smarter. These 5 steps took us from concept of to production in less than 2 months. Earlier, every encoded PowerShell command triggered an alert, whether it was a hacker or an admin running script. After applying ML, machine learning, the system learned the difference, reduced the noise by 80%, and even stopped the ransomware before it spread. That's the story in one sentence: simple, measurable, and real. And so basically, these are the references I used for that particular presentation. And I have one more small presentation. If you are asking about how actually we implemented the concept of artificial intelligence to improve our existing system, this is something. One more thing. can you see my screen? Okay, so this is one more presentation. This is again a small presentation, but this shows you how in our real project, how from our work environment, how we transform one of our enterprise.NET Core system by implementing the observability-driven security. This is not just this is the proof of a concept. It was actual production change that helped us reduce the detection time from hours to minute and bring the security, development, and operations under one connected view. Uh, get back to your question, I think you asked earlier how we implemented, and when I was answering about the and talking about the observability, this presentation will give you idea how actually we implemented it. The project involved a large-scale .NET Core web application, which we are using, that supported the multiple brands, managed customer pricing workflows, and processed thousands of daily transactions. The architecture was service-based, multiple APIs, SQL Server integration, background jobs, all running in a hybrid Azure environment. Initially, our biggest pain point was visibility. We had a separate tools for uptime monitoring, database performance, and application logs, but no way to correlate them. Security and the performance were treated as two different worlds. As I mentioned, to secure anything, you have to first able to view the entire system, right? You can't protect anything, something which you can't see. Before we implemented the observability, everything was reactive. We detected incidents manually, sometimes several hours or after they started. For an example, a credential stuffing bot once hit our login API continuously, and the system was slowing down. But since the CPU and the memory were stable, none of the traditional alerts fired. We realized only after the customer complaints about it. Logs were stored on different servers, and correlating them across the service took several hours. Our mean time to detect was about 6 hours, and the mean time to respond was about 8. At that point, we realized we needed better visibility. Now, not and we don't want any more additional tools. That's when we introduced the observability-driven security. We started by implementing the serial log for structured and centralized logging, so we could see what application logs in one place. Then we added the open telemetry tracing across all microservices. That gave us the end-to-end visibility for every request from the API layer down to SQL. And finally, we integrated everything into the Azure Application Insight and Sentinel. This brought together performance metrics, trace, and security alerts into a single dashboard, giving both developers and the security teams a shared real-time view. The impact was immediate. Anomalies that used to take hours to detect were now visible within minutes. The results were measurable and significant because every result which are measurable, that actually easy to present to the management. So mean time to detect dropped from 6 hours to 12 minutes. Mean time to respond dropped from 8 hours to 45 minutes. Incidents that require cross-team troubleshooting could now be identified instantly through the trace data. What used to take a war room of emails and a log exports now happen automatically with a complete transparency across the team. Our dashboards now show the both performance and the security indicator side by side, which means every developer can see if the performance issue is actually a security symptom. The biggest change wasn't just technical, it was cultural. Observability helped us to break down the silos between the developers, operations, and the security teams. We stopped reacting to the outrage and started anticipating risk. As I often say to my team, before observability, we reacted to the incidents. After observability, the system started defending itself. That's the power of observability-driven security. It turns the data into the defense and complexity into the clarity. So yeah, that was means those are two examples how I use the AI and the concept of AI to improve our existing systems.
Great presentation there. And Bashka, you really do know how to make good presentations about the things you do and the projects that you've worked on, and I really must commend that. So moving forward, looking at the near future, what emerging AI capability or technique are you most excited about that could fundamentally change the cybersecurity game, say in the next 3 to 5 years?
So, if I understand your question, you are asking where is the AI in means I can tell you where the AI in business heading next. You know, so if you ask me that, I can say it's towards the explainability and embedded AI, not the standard or dashboards. AI will be the part of every workflow going forward, recommending, guiding, and validating and learning continuously. Think co-pilots instead of the business, not a black box outside of it.
All right. So, what gives you the most hope about our ability to use AI to create a more secure digital world, despite the escalating threats and the bad guys using AI also for attacking?
Right, right. So when we talk about the AI, you you can use the AI to prevent something. No system is 100% secure, and as I mentioned in my earlier conversation, AI tools are available for the attackers as well as the programmers or the people who are defending it, the cybersecurity people. So you have to learn how you can use the concept of AI to prevent those attacks. AI have so many concepts and so many tools. We have to think of the mindset of the attackers, and we have to think about the how we implement those concepts. And so how can I put it in word? So AI has so much uh, capability and so much future. We just need to learn how to use it, how to implement it in our existing organizations. We have to teach the people how to actually AI is just a tool, right? Unless people who are using the system, or who are actually using the part of the cybersecurity people, we need to tell and learn, teach the people using the websites to how to use it more. As I mentioned in my presentation, the main topic of this presentation, the habit is more important than actually to implement the security.
All right. All right. So, tell us, what does the word innovation truly mean to you?
Innovation, okay.
Yeah.
Innovation is obviously build something new, but in today's world we have so many things, right? And instead of building new things, whatever we have, if we try to improve those things, that is also, I think, in my terms, is a part of innovation. Obviously, improving new things and creating new things is innovation. But whatever we have right now, making it more secure, that is also a part of innovation for me.
Fantastic. So finally, for our listeners who wants to follow your work and continue the conversation, so where can they go to find you or connect with you?
Okay, you can visit my LinkedIn profile. um, Let me share the screen where I have my LinkedIn profile. So if you scan this, it will redirect you to the LinkedIn profile. You can message me if you have any concern or any questions regarding the presentation, or like normal question, how to implement the AI in your existing environment. You can reach me here. This is my LinkedIn profile barcode.
All right. So Bashka, it's been a really great and insightful conversation with you, and I am excited to have you on the show today.
Thank you so much.